Hi all, this is Mr. Yeager for AP Physics 1. This is the first recording for the unit on energy, in particular work and energy. This is going to be a very important unit because this puts together pretty much everything that has been covered so far in kinematics and in forces, whether you consider it an equilibrium or a dynamic. We'll be able to use energy to describe all of those situations. In addition, it's going to help us describe situations where the acceleration changes. So we'll talk about that in another slide a little bit later. But the thing is, this is a very important unit. When I solve problems and I see it's a motion problem, an object's in motion, the first thing I always try to think of is, can I solve this using energy? And that's what we're going to try to cover during this particular unit. So, through these recordings, we're going to look at both the what is internal versus external in the system. What does that mean? What are we referring to there? We're going to look at work. We're going to look at force curves. And we're going to look at the work energy theorem. All right, and that is the big one. That is the formula part that we'll be able to manipulate quite a bit in multiple different scenarios. So, the thing is, we need to start off, what is energy? We need to do some sort of introduction. You've been in physical science in 7th, 8th grade or in another time. You've learned about energy, and the basic definition for energy is the ability to do work. All right, which means if you have energy, something can happen, basically. It's very vague. It's one of those ideas that actually back in the 17, 1800s, they were struggling with the idea of energy just because you couldn't really grasp it, but it was causing all of these occurrences. Everything in basically physical motion in the universe is based on the energy that it has. So it's able to do work, is what energy is really referring to. Obviously, we've heard of the law of conservation of energy. Energy must be conserved. That's looking throughout the whole universe. All right, there has never been any creation or destruction of energy. Energy must remain total within a particular system. All right, but it can change forms. All right, now if I say this universal system, now within a system itself, it is possible to increase or decrease that energy, but it then must have come from another source outside the system. As I was saying, the importance of the energy unit. We can use energy problems when acceleration changes. One drawback you probably learned about in kinematics is that will only work when you have a single acceleration. All right? If the acceleration happened to change in the problem, you have to go back and plug it back into the equation again. If it changed again, you have to do another equation. You have to keep doing a new kinematic equation every single time that the acceleration changes. But with energy, you don't. You can find one particular equation that will work within this energy unit when we do the work energy theorem, and guess what? We can get the answer, which is why try energy first. Okay, when you try to do a motion problem, try energy. It'll actually usually take care of quite a few problems. So, starting our real big first topic, the idea of systems. Okay, what is a system again? You probably learned it during dynamic forces, doing Atwood machines, pulling multiple objects, moving multiple objects. So again, a system itself is a collection of objects. Okay, multiple objects that you're putting together to look like a single object. All right, anything that's part within the system. All right, when we did forces, we actually ignored. We only looked at the external forces of the system. We're going to do a similar thing in this unit as well. Okay, what will be external, what will be internal to the system. This is important because it turns out potential energy is something always stored within the system. You've learned about potential energy as being stored energy. Okay, stored energy. That is stored within the system itself. It's the ability of the objects within the system to change that energy into another form and interact with the outside universe. All right. So the big issue here, this is one of those first initial tough things with energy, is you cannot have potential energy unless you have at least two objects. It must be created by the interaction of minimum two objects. Okay? And usually that's all we're going to look at. There are two types of potential energy out there. We're going to focus on one in this unit, but I'll introduce the other one. The main one we're going to use in this unit is gravitational potential energy. This is energy that occurs between the object and the Earth. It's the idea of energy based on height. Okay, but the thing is, it doesn't always have to be height. All right, it has to be the gravitational attraction between the two. All right, but the thing is, I have objects on my shelf in my room. All right, the objects on top, I always just say, have potential energy, but alone.
Carson Scott, please return to the main office. Carson Scott, please return to the main office. Thank you.
All right, sorry about that announcement. All right. We have objects on top of my shelf in my room. All right, you can imagine those objects are on the very top. We would say they have potential energy because they have that potential to fall. Their potential energy can change into kinetic energy. The thing is, why would they fall in the first place? What's going to pull them down? What would be attraction for them to fall down? And that would be the Earth. So when I say they have potential energy, I have to say this object, this Buzz figure, must have potential energy because it's Buzz versus the Earth. Okay? Sorry, I'm a Georgia Tech fan. All right? Buzz versus the Earth. All right? The thing is, he doesn't have potential energy alone. It's his interaction with the Earth that creates that potential energy. Same thing goes for elastic potential energy. You cannot have elastic potential energy alone. But the idea is, if you have it interacting with a spring, you have that possibility that you can create that elastic potential energy. At least that's how it's going to be done within AP physics. Okay? So, potential energy is always, always, always internal to the system. All right? And that's going to be important much later when we get to the third topic of the work energy theorem of when is energy lost, quote unquote, lost from the system versus when is it conserved within the system. Now, what about kinetic energy? All right. These are going to be our main two types. I know there's thousands of other types out there: chemical, electrical, magnetic energy. I mean, all these other types of energies are out there, but we really will only focus on potential and kinetic energy. Kinetic energy, again, you probably know based on the second line there, it is the energy of motion. Okay, that's been something you've known for a while. The thing about kinetic energy is it can occur alone. If you look at just the object itself, it could be moving, and it's moving because it has kinetic energy. All right. So, kinetic energy doesn't have to be within a system. It can be by itself. All right. And that's what's stated in the middle here. The object can have its own motion and can change its motion internally. All right. Now, that would be the thing is, where would it get that kinetic energy to change? That would be from the potential energy within the system itself. So if it does have some sort of interaction, we can change that energy. Okay. Alone, it can't change its energy. It can have it, but it cannot change it. All right. And so that's basically getting into our big idea here. What if we want to actually change the potential energy or kinetic energy of the system? What can we do? What can we try to apply to the system? What can we do? All right. Well, what we can do is we can apply a force. All right. Especially if you just think about kinetic energy. Kinetic energy is the energy of motion. Well, what if I want to move faster? What do I have to do? The only way to accelerate is to apply a force. All right. And so any push or pulls or friction, they are always going to be something external to the system. All right. We almost never will sit there and say it's the object in the ground. All right. Then obviously we can include friction within the system, but that doesn't happen. All right. We're looking at the object itself and what is acting around it. All right. Around that particular system. And so what we have for just the next few slides is a couple of pictures, and we're going to look at these and go, okay, what type of energies might they have, and what would be something that could change the energy of the system? What would be the system itself? Can you identify the system that I'm talking about? So this first picture here, fancy car, okay, crazy color. What can we talk about this? What would be the system in this particular picture? We're obviously trying to show that this car is moving, okay? So it does have kinetic energy, and that can be alone. That's all we need to look at. We can just say, there's the car, it has kinetic energy, okay? The thing is, what could change the kinetic energy of this object, all right? Well, we could look at the ground. What could the ground cause? It can cause friction, all right? And what's friction going to cause the car to do? It's going to cause it to slow down, which means what's being lost by the car. Okay? Friction would cause a decrease in kinetic energy if it's able to slow it down. Okay? Now here's a weird one, and maybe this one might be one we have to discuss a little bit, or you might have questions about later on. Okay? We might say, what if it wants to get faster? Well, that would be the engine. And I know my students always get mad. They go, well, isn't the engine part of the car? Well, yes, okay? But, and yes, it is moving. I can't deny that or anything like that. But we're going to say the engine is not part of the system of the car body that's moving. I'm looking at the car body, and that's my system moving along. Because if I could say the engine's acting externally because it creates that drive to make it go. If I include it in my system, then we get a whole mess of chemical energy from the gasoline changing into mechanical energy, and it just keeps going on and on and on and on from there. So the thing is, I try to keep the engine outside of the system, all right? And I know that's a little bit tough one to think about, but the engine would make the car go faster, it would make the car body go faster. Friction would make it go slower. These are external forces to the system itself. Next picture. This guy parachuting. All right. What energies would he have? What energies would he have? Well, we'd probably say that he'd have kinetic energy. He's probably moving. I doubt he's just sitting in midair. Okay. So he'd have kinetic energy. And we'd say he has gravitational potential energy. All right. So he has these two types of energies. The thing is, where does he get these types of energies? Okay? Again, kinetic can be alone. He can just have it because he's moving. Okay? That's the person. If I just focus on the person alone, that would be the system. The person alone. Okay? The thing is, I said he has gravitational potential energy because he is above the ground, and I'm pretty sure this gravitational potential energy is changing into kinetic energy. Okay? I can make that pretty big assumption there, right? So, the thing is, why does he have gravitational potential energy? What's giving him that ability to have gravitational potential energy? And that's because we would say the system creating this would be the person interacting with the Earth. That is what gives us the gravitational potential energy. And as the Earth keeps on pulling that person down faster and faster, we can see the energy of the system change from gravitational to kinetic energy as it gets faster and faster going toward the ground. Now, there's probably one more I can include here that can actually pull energy away from the system, and that's probably the air resistance. Sorry, that got really dark there. The air resistance pushing up. And so the air would not be part of my system, and that would create a pool of energy out from the system. It's working against the motion. All right? We're going to talk about that in a minute. We would say it's going negatively compared to the direction of motion. So it actually is going to lose energy. See, I have two more pictures. All right. For this particular one, pot of water, okay? We'd say probably the water molecules, okay? If we talk about I'm going to just write H2O molecules. They have kinetic energy because they obviously are getting higher temperature. Temperature is average kinetic energy. They are starting to move faster and faster and faster. So really the only one I wanted to point out here would be, again, what's external to the system, what's providing this increase in kinetic energy. That would be the heat down here, okay? The stove, all right? The thermal energy is supplying the kinetic energy. It's converting from thermal into kinetic energy for the object itself. Last picture. All right. Trampoline park. Again, we have to try to focus on a particular area, see what we can do, or a particular person. All right. This one we can have multiple different types of energies, and it depends on the system you're looking at. All right. You're looking at maybe if you want to, we can look at just a single person. Okay. change colors here. We can look at a single person. All right. If we're only looking at the person all alone, that person only has kinetic energy, so it's only based on how fast they're moving. Okay. If I want to look at somebody that I want to see that they have kinetic and potential energy, then I'd have to say that I'm looking at the person with, again, what? The Earth. And then finally, we have one more that we can look at. We have another type of energy. What type of energy would come from the trampoline? That type of energy would be elastic potential energy. So how would I say that? Maybe she has gravitational potential energy, kinetic energy, and elastic potential energy. What would be the system there? That would be person, Earth. That gives me my gravitational potential energy. But I can add the spring in, and that would give me my elastic potential energy as well. Obviously, at this time, if she's up in the air, she has zero elastic potential energy. It probably converted from elastic to kinetic, all right, kinetic to gravitational, and then vice versa. It goes back. And as long as we don't look at anything else, like air resistance, technically that's causing some changes, or maybe it could even be the person's muscles pushing. We're going to ignore that. If we only look at just the person, the earth, and the spring, those three things, those three types of energy should continue to convert one into the other.